Today we're going to talk more about perpendicular lines. Particularly, there are a couple of theorems about perpendicular lines that we're going to go over. The first theorem about perpendicular lines says, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. In other words, here are two lines G and H. If they intersect, and you know that they form a linear pair that are congruent, that means you know that the lines are perpendicular. Now, if you have a linear pair, that means that the two angles must add up to 180 degrees. And if they're congruent, then they have to be the same angle measure. In that case, they would have to be 90 and 90. Now, if you form 90-degree angles, you know that the lines are perpendicular to each other. The next theorem says, if two lines are perpendicular, then they intersect to form 4 right angles. So in this case, if you know that two lines are perpendicular to each other, not only do you know that angles 1 and 2 are going to be 90-degree angles, but similarly, you would be able to say that 3 and 4 are also right angles. Why? Well, because if 1 and 2 are a linear pair and congruent to each other, and so they're 90 degrees, then that means on the other side, the other two angles must also form a linear pair, and they also must be congruent to one another. This means that all 4 angles are right angles. The next theorem says, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Okay, so this is saying here, we have two adjacent acute angles. So acute meaning less than 90 degrees, and adjacent meaning right next to each other, they share one side. And it says if two sides, so the side set is not common to the angles, if those two sides are perpendicular, then the angles are complementary. Well, if they're perpendicular, that means they form a 90-degree angle. And so if those two adjacent angles are next to each other, they form that 90-degree angle, then that means they must be complementary. So here in this case, we would say if BA is perpendicular to BC, then angle 1 and angle 2 are complementary. Now, with theorems, you do actually have to prove them to be true. We're not going to be going through every single proof for every single theorem, but every now and then we'll take a look at some of these proofs. So we'll look at the proof for this theorem. Okay, so let's say we're looking at this diagram here, and we're given that ED is perpendicular to EF. And we need to prove that angle 7 and angle 8 are complementary. How do we do that? You always want to start with what you're given. So we know that ED is perpendicular to EF. From there, what can you say? Well, you can say that the angle DEF has to be a right angle because you know that perpendicular lines form right angles. Well, we also know that the measure of angle DEF has to equal 90 degrees because that's the definition of a right angle. Now, by the angle addition postulate that we've gone over, we know that the measure of angle 7 plus the measure of angle 8 is going to equal the measure of angle DEF. Now, by substitution, that tells us that the measure of angle 7 plus the measure of angle 8 is equal to 90 degrees. And from here, we can say, well, angle 7 and angle 8 are complementary because that is simply the definition of complementary angles, that they add up to 90 degrees. All right, let's get back to our theorems. So theorem number 4, the perpendicular transversal theorem. This says, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Here's a diagram to understand what we're talking about here. So the transversal here is J. And so what this theorem is saying is, if you know that J is perpendicular to H, then you know that J must also be perpendicular to K. Now again, this is only true if you know that H and K are parallel lines. So if H is parallel to K and J is perpendicular to H, then you know that line J must be perpendicular to K as well. All right, theorem number 5. Lines perpendicular to a transversal theorem. Now this one says, in a plane, if two lines are perpendicular to the same line, then those two lines are parallel to each other. All right, so as an example, we have a diagram here. So this theorem is saying if two lines are perpendicular to the same line, so if M is perpendicular to P and N is also perpendicular to P, then you must know that M and N are both parallel to each other. All right, that's it for the theorems. We're going to go over a couple more things. So here's a definition. The distance from a point to a line is the length of the perpendicular segment from the point to the line. So usually when we're talking about distances, at least up to this point, we've only talked about the distance between 2 points. Anytime you're asked what's the distance from this point to that line, well, there are a number of ways you can draw that. But the length that we're talking about when we're talking about the distance is going to be the line that you draw that is perpendicular to the line from that point. The segment will end up being the shortest distance between the point and the line. So here's a picture for us. So here we have line K and we have point A. Now the blue line that's drawn here is what we call the distance from point A to line K, and you can see that's the shortest distance from the point to the line, and it is perpendicular to line K. Now if we were talking about the distance between two lines, if they were two parallel lines, then we are talking about the perpendicular segment. And we know that if those two lines are parallel to each other, then the line segment that is perpendicular to one must also be perpendicular to the other. Let's work through an example. Find the distance from point A to line C. Round your answer to the nearest tenth. Now in order to do this, we need to find the perpendicular line that starts from point A. Really what we need to do is, in order to find the perpendicular line, we need to find the slope of line C, and then find the opposite reciprocal, and then, once we've drawn that line, then we can find the distance. So let's start by finding the slope of line C. So to find the slope of line C, I'm going to go ahead and use rise over run. So it looks like we are going to go up 6, and then over to the right 2. So 6 over 2 is equal to 3. So the slope of this line is 3. Now if we're trying to find the line that's perpendicular to line C, we're going to need to find the opposite reciprocal. So the opposite reciprocal of 3 is -1/3. So now let's start at point A and draw in that slope. So we go down 1 and to the right 3. So that is the line. Now since we're trying to find the distance from point A to line C, we don't need that entire line. We just need that line segment. So just this portion here. So we know that at point A, that's at 0, 2, and the point that it reaches line C is at 3, 1. So to find this distance, now we can use the distance formula. D is equal to x2 minus x1 squared plus y2 minus y1 squared. So this is going to be 3 minus 0 squared plus 1 minus 2 squared, which ends up being 9 plus 1 under the square root, which is the square root of 10. You can leave it as the square root of 10, but here it says to round your answer to the nearest tenth, so that's going to equal 3.1. So the distance from point A to line C is 3.1.